To be a master software developer, it's necessary but not sufficient to have expertise in several things. For example, it helps to be an expert at modeling notations, which help us to visualize the structure and behavior of software. It also helps to have expertise with algorithms, which provide step-by-step procedures for expressing calculations and computations. Naturally, it's important to have mastery of programming languages, which define formalisms for controlling the behavior of computers and being able to express algorithms precisely. But to really become a software master requires more than just knowledge of modeling notations, algorithms, and programming languages. It's also very essential to understand how well-designed software exhibits recurring structure and behavior. And knowledge of this recurring structure and behavior helps to enhance a variety of key software quality attributes, including things like abstraction, which allows us to be able to emphasize what's important and de-emphasize what's unimportant in a particular context or at a particular level of detail. Flexibility, which allows us to be able to apply components in ways that may not have been anticipated when the components were originally developed. Reuse, which is similar, but allows us to be able to take components developed before and apply or reapply them in new contexts where they may not have been intended to be applied initially. Of course, quality is important to ensure that bugs are eliminated, vulnerabilities fixed, and the code becomes more hardened and bulletproof and resilient. And naturally, also important quality attribute is modularity, which allows us to be able to divide and conquer a big problem space into smaller chunks that have low coupling and high cohesion, so individual developers and teams can work together more independently and with less coupling on each other. There's clearly some valuable design experience that lurks in these recurring structures and behaviors. So what are the issues? Well, one of the big problems we've had historically is it's been very difficult to access this design experience. And that's because it's often been in one of two places. It's either been locked in the heads of the experts, or it's been buried deep in the bowels of the source code. And both of those locations are fraught with danger. If it's locked in the heads of the experts, this design expertise is likely to leave when the experts go on to their next job. Likewise, if this experience is deep in the bowels of the source code, it's very difficult to extract and understand how the various pieces work together. So what we need is some type of principled means of being able to extract, document, convey, apply, and preserve this design expertise without undue time, effort, and risk. And that's what we'll talk about next.